Hi everybody, it's Mrs. Mancuso. I'm going through the January 2018 exam. This is the 4th video in the series and we are now on part C. So write the empirical formula for tetrachloroethene. So C2Cl4. Empirical means I just want to reduce it. So a 2 and a 4, that would just be CCl2. All right, next one. Thermal energy is absorbed as chemical reactions occur during the process of baking muffins. The batter often contains baking soda, which decomposes as the muffins are baked. The balanced equation represents this reaction, which releases carbon dioxide and causes the muffins to rise as they bake. The water is released into the air of the oven and it becomes a vapor. So there's the reaction. Based on table E, identify the polyatomic ion in the solid product of the reaction. So here's the solid product of the reaction. The polyatomic ion is CO3. So you go over to table E and you look up CO3, and CO3 is carbonate. So you just want to write that right in. Carbonate. All right, now if you wrote out CO3, you could write out the ion. So you would write out CO3 negative 2. That's also what it is. I've identified the ion, whether I write it out this way or I name it. State the direction of heat flow. So heat always goes from where it's hotter to where it's cooler. So I need to do it between the air in the oven and the muffin batter. So the air in the oven is obviously much hotter than the muffin. So the heat travels, heat moves from the air in the oven to the muffin batter. Man, these are making me hungry, these problems. All right, so you've got heat always moving from where it's hot to where it's cooler. The batter is much colder than the oven, so I've got to show the direction, and I write it exactly like this to make it point-worthy. All right, compare the potential energy of the liquid water molecules to the potential energy of the vapor. Well, if you picture a curve, here is my liquid and here is my gas. There is going to be greater potential energy in the gas molecules. So I just would write that. There is greater potential energy in the water vapor molecules than the liquid water molecules. All right, so I always, when comparing, I got to state both. All right, state the number of sig figs used to express the pressure at the surface of the lake. So here is the pressure at the surface of the lake. Both of those have 4 sig figs. Okay, so the 1, the 0, the 4, and you'd only put a 0 after decimal if it actually mattered. So 4 sig figs, and this one 4 sig figs. All right, show a numerical setup for calculating the volume of the bubble at the bottom of the lake. So here's the volume of the bubble at the bottom of the lake. I want to do P1 V1 over T1 is equal to P2 V2 over T2. So I would set that up because I just have to do the setup. So I'm going to take the pressure, so that's 104.0 times 2.5 divided by 293, and that's equal to 618.3. Sorry, you know what? I'm going to have to do this on a separate page because I really just can't fit it. 104 point, oh, I also can't remember it. 104.0 times 2.5 over 293 is equal to 618.3. times V2 over 282. That's the correct numerical setup. Leave it just like that. You plugged everything into its parts, and that is all you need to do to earn that point. All right, I'm going to erase this because it is just so messy right here. All right, next one. Determine the mass of the air in the bubble at the surface of the lake. So at the surface of the lake right here, I know the density. So density is equal to mass over volume. So my density is 0.0012, and that's equal to m over, the volume is 2.5. So that means m is going to be equal to 0.0012 times 0.0012 times, oh my goodness, my calculator. Sorry, 0.0012 times 2.5. I get 0.003, and it's asking me for mass, so that is in grams. So that would be the mass. All right, next one. Nitrogen dioxide, NO2, is a dark brown gas that's used to make nitric acid into bleach flour. Nitrogen dioxide has a boiling point of this and this in a rigid cylinder. It can be at equilibrium. All right, state evidence from the reaction that the forward reaction is exothermic. So I have to have evidence, so I can say the forward reaction produces 58 kilojoules of heat. So if I have an exothermic reaction, I have a reaction that makes heat or produces it, and so there it is. If it's on the product side, it's producing it, so that's exothermic. 74, compare the rate of the forward reaction to the rate of the reverse reaction. If it's at equilibrium, the rates are equal. Remember my saying, anytime you have equilibrium, your rates are equal and your concentrations are constant. State one stress other than adding or removing NO2 or N2O4 that would increase the dark brown gas. All right, so first of all, I got to go up here. Nitrogen dioxide is dark brown. So this side is brown, and it's used to make nitric acid. So this side is my colorless. So I'm going to write clear on that side. So state one stress other than adding or removing that would increase the amount of dark brown gas. If I want to increase the dark brown gas, I want to go this direction. So I would say the easiest thing to do, there's 58 kilojoules right here, so increase the temperature. If you increase the temperature, you are adding right here, which makes it shift to the left, which would increase the amount of NO2, which would make it brown. Another thing you could do, there is gas on both sides. So there's 1 mole of gas on this side, and there's 2 moles of gas on this side. So if you increase the pressure, you would favor the reverse reaction because you'd make it go to the side with less moles. So another thing you could do is decrease the pressure. If you decrease the pressure, it's going to favor the side with more moles of gas, and there's more moles of gas on this side. All right, at standard pressure, compare the strength of the intermolecular forces in NO2 gas to the strength of the intermolecular forces in N2 gas. All right, so nitrogen oxide has a boiling point of 294. So I just want to write that real quick. This one's 294. And now I could look up the boiling point of nitrogen gas. So I go to table N. I know nitrogen is a gas, so it's going to have a pretty low, at standard temperature, it's going to have a pretty low boiling point. So I look it up. The boiling point is 77. So to compare the strength of intermolecular forces, I would write that NO2 has stronger intermolecular forces, I would write that out on the test, than N2. And so because it has a higher boiling point, I know it has stronger intermolecular forces. All right, determine the oxidation state of nitrogen and nitrogen dioxide. So nitrogen dioxide is NO2. I know oxygen's a -2, so that means this nitrogen, two -2s must be balanced out by a +4. So the oxidation state of nitrogen is a +4. Okay, a student sets up a voltaic cell using magnesium and zinc. The diagram is shown below. Determine the moles of Mg+2 ions produced when 2.5 moles of zinc react. So this is already a balanced reaction. So if I have 2.5 moles of zinc react, I would need 2.5 moles of magnesium. It's all balanced. So 2.5 of these and 2.5 of these would make 2.5 of those and 2.5 of those. State in terms of ions how the barrier functions as a salt bridge. So the function of a salt bridge is to transfer ions between the two cells. State in terms of relative activity of the metals why the reaction occurs. Okay, so in this reaction, it is voltaic. So whichever one is higher on table J is going to be oxidized. So Mg is higher than Zn on table J. So Mg, this side is going to be my anox, and this side is going to be my red cat. And if you look down here at the reaction, Mg is a 0, and here it's a +2. So Mg is oxidized, and then zinc is going from a +2 down to a 0, so this one is reduced. All right, so state in terms of the activity of the metals why this occurs. Magnesium is more active than zinc. Okay, so in terms of activity, this is oxidized because it's more active than Zn. All right, write a balanced half reaction for the oxidation that occurs. So Mg becomes Mg+2, plus it loses 2 electrons. That would be my oxidation half reaction. I got it from right here. Mg is becoming Mg+2. I remind myself oxidation's losing electrons, so I have to show the electrons lost over here. The oxidation number always goes up, so here it is going from a 0 to a +2. All right, polyvinyl chloride, PVC, is a polymer used to make drain pipes, flooring, electrical wire insulation, and some plastic bottles. Making PVC requires several reactions. The first reaction is there. And then I'm going to go down to the question. So explain in terms of chemical bonds why reaction 1 is unsaturated. So the hydrocarbon in number 1, this is an ethene. So it is unsaturated because it has a double bond. There is a double bond between the two carbon atoms. So if something is unsaturated, it has to have either a double bond or a triple bond. I noticed that it was an ene, which would tell me it has a double bond. Identify the class to which the product of equation 1 belongs. Here's equation 1. Here's the product. I go over to table R. That shows me all of my classes. Because it has chlorine on it, it is a halide. That's the class. All right, 84. Draw the structural formula for the product of equation 1. So I need to draw this. So I need to erase this so I can see it a little better. 2 C's. All right, 1,2-dichloroethane. All right, so I'm going to go down here where I have some space. Oops. There's ethane, 2 carbons. 1,2-dichloro means one comes off the first carbon, one comes off the second carbon, and then the rest of the spots will be H's. I'm always filling my rule of carbon forming 4 bonds. So there's my structural formula. And then the last question, state the number of electrons shared between the carbon atoms and a molecule of vinyl chloride. So I go up here, vinyl chloride is right here. There's a double bond. So a double bond is 1, 2, 3, 4 electrons being shared. So the number of electrons shared would be 4. All right, thanks for joining me. That is the end of the January 2018 exam.